All right, it's Algebra 1, the final review for the final spring 2026. I'm here with a bunch of delinquents that have decided they are ready to actually learn some math. We're going to be doing 6, 7, 8, 9, and 10. The request has been to do the basics first. I will upload all of this. What's up? I'm going to upload all of this afterwards, so if you don't want to write stuff down, that's totally fine. You don't have to, because I'll upload it and you can just look at it on your Chromebook. Let's go ahead and do it. You're going to tell me which ones you want to skip. Actually, no, let's do it this way. Tell me which ones you want to do. So there's no no's, there's only yeses. If it's silent, I'll know to skip. Does anybody want to do the red, blue, green marble question?
No.
I want yeses only. We are fantastic listeners. Didn't hear any yeses. What about the population proposition 16 question?
Yes.
There's a yes. We know 5/9 of the population voted. What we want to know is how many total people there are, right? We want to know what P is. Well, if 5/9 voted, how much didn't vote? 4/9 of the population didn't vote. And we know how many people didn't vote. How many people didn't vote? 64 of them. So we've got options. We can either times by 9 first or divide by 4 first to get what the total population is. I'm going to divide by 4 first because, like, that's better than timesing by 9. So if I divide by 4, what is 4/9 divided by 4? 1/9. And if I divide 64 by 4, that is 16. Yeah, we're used to that 4 cubed, huh? And if we times by 9 now, it's going to be a little bit easier. We get 90 and 54. What is 90 and 54? Yeah, it turns out 9 times 16 is 144. That's kind of weird, huh? But if you think about it, 16 is 4 times 4, 9 is 3 times 3, 4 times 3, 4 times 3, 12 times 12, 144. Should we do the kilograms and pounds and weights thing? I need to hear a yes only, otherwise just be silent. Grace, good job. I didn't hear any yeses. Okay, moving on. Visiting Slovakia. Should we do the Euro question?
Yes.
All right, the key here is, for the love of God, do not use long division. Stop. Just get common denominators and circle your answer. It's going to be gross. We're doing an exchange rate between euros and dollars. It's going to be awful, which is why you go to the exchange station first before you go out to eat, you idiots that are going to a restaurant and just handing them $15 and being like, just give me the change. Shame on you. So here's what we're going to do. We're going to take that $15 that we gave them, and we are going to actually convert it to euros first, which is exactly what you should be doing before you go to the restaurant. To do so, we're going to divide by dollars because dollars divided by dollars goes away, and what we want is euros. So we'll multiply by euros. If only I knew how many euros were in a dollar, how many dollars were in a euro. Do I know this? I do. What do I know? 1 euro for $1.32. So that means we're going to times by 1 and divide by $1.32, and what we're going to get is euros because the dollars divide out. What is 15 times 1? 15. They said so confidently, yes. And then we're dividing by $1.32. Stop. Do not pass go. Do not collect $200. Do not divide this with long division, for the love of God. So we're giving them this much, and it costs 10 euros. So to get our change, we're going to take this, and we're going to subtract 10 euros. Now, Grace, we need commie denomies, don't we? So let's go ahead and multiply by $1.32 over $1.32. That won't change anything because that's just timesing by 1. And what we're going to get is 15 over 1.32 minus something else over 1.32. That was the whole point. Luckily, 10 times 1.32 is pretty easy. What is 10 times 1.32? 13.2. Do not tell me that the answer is just 15 minus 13.2. No, we need the commie denomi. It's going to be gross. There's no way around it. Let's do 15 minus 13 first. What is that? 1.8. Try again. 15 minus 13 is dose, and then we take away 0.2, which is going to be 1.8. Jeez, Landry. So that's going to be the change. You're going to notice that it's like a little more than a euro. It's like a euro, and then we got like, what, 0.6 over, or sorry, 0.5 over 0.3 left over. So that's like, you know, not very much at all. That's the exact change. No rounding needed. All right, questions on that one? Don't get commie denomies, or sorry, get commie denomies, do not long divide. Thank you. Percents, yes, no? Wait, nope. All I want to know is yes. Percents?
Oh, wait, yes.
We were so close. We were so close. We were so close following directions. By the way, for those of you following along at home, this is the peak, the pinnacle of my students because they are locked in right now because they are desperate to pass. So whatever you're experiencing right now is their like A+ game. I never get their A+ game. I get worse than this. But this will have to do. What number, that's X, that's an equal sign. 52% means this. And what does of mean in math? Multiplication. So of 300 is this. This is the setup. I'm going to set up all of these, and then we're going to go back and talk about them. What percent is meaning this? Percent means per 100, right? Per century. What percent of 150? That means times 150 means equals 66. On this next one, it says 255 is. So that means 255 equals. 85% is 85 per 100 of what number? And this is what we got to solve. Now, all of these are kind of puzzly. You need to be able to do this in your head without a calculator, and so you're going to try and find simple ways to make this better. So, for instance, this is saying we need to times by 52 and divide by 100. It doesn't matter what order we do it, though, right? So why times by 52 when you could divide by 100 first? What is 300 divided by 100? It's just 3. So we end up with x equals 52 times 3. And that's really easy, right? 156. Done. This says divide by 100, but isn't this just 50 times 2? And this is 50 times 3. So what if the 50s divide out? Well, then we end up with x over 2 times 3 equals 66. It's a little bit easier to work with, isn't it? This is 50 times 3. This is 50 times 2. And it says divide by 50 and 2, so let's divide by 50. We get 3 and 2. At this point, we got to get x on its own. So we're going to times by 2 to get rid of this and divide by 3, right? It doesn't matter what order you do it in, but if you can divide, you get smaller numbers, which is nice. So I'll divide by 3 first. If I divide by 3 first, this becomes 22, right? 3 divides out here, you get 22. Half of something is 22 times by 2. You're going to get 44. How are we feeling? J-Dog? Good, don't. Pay attention and learn. I'm going to have all of this scanned and sent to you. All right, this guy. We could times by 100 and then divide by 85, but we should probably simplify first because none of that's going to be super easy to do. What common factor do 85 and 100 share? They share a 5. This is 5 times 20. And that's 5 times 17, fun fact, right? 50 and 35. Yo. 50? Nah. 15? 15 doesn't go in 100. 100's not a factor 15. So, we're going to times by 20 and divide by 17. Fun fact. 17 actually goes into 255 evenly. Isn't that kind of gross? But it's true. We already know that 17 times 5 is 85, right? What's 17 times 10? 170. If you put those together, 17 times 15 is 225. It's true. It's true. It's true. It's true. This is 225. Or 55. 55. Yeah, it's whatever that number is. Sorry, 255. So yeah, that means if we divide by 17, this becomes 1/20th. And if we divide this by 17, what are we going to get? 15. That's kind of nice, huh? And if we times by 20, well, 20 times 3 times 5 is going to be 300, right? 20 times 3 times 5. So 300 equals x. Times by 20. Puzzles. All right, let's pause for station identification. How's the speed? Too fast, too slow, just right? It's too slow? Harper, shut up. You can say shut up. What you're not allowed is to beat children. Harper? I threw a bowling pin at her off screen. All right, so are we down with the plan to just do all the basics first? All right, flipping this to 7. Let's do basics on 7. Fun fact, this is exactly what the other 2 classes did that met, and I uploaded videos for those things, so good job watching those videos. All right, chocolate chip cookie recipe. This is 7. This is talking about proportions. So we're going to have different types of relationships. Let's talk about the 2 main kind. There is directly proportional. What does directly proportional mean? Well, I think yeah, what he's trying to say is right. If one goes up, the other one goes up. Or if one goes down, the other goes down. Now, this isn't obvious until you think about it, but this type of relationship is a division relationship. And here's why. Imagine I have 50 over 5. That is equal to 10, yes? So the relationship is 10. The relationship is not allowed to change. If I turn the 50 into 100, what am I going to have to turn the 5 into? I'm going to have to turn it into a 10. Do you see how as one went up, so did the other? Otherwise, the relationship would have changed, right? 100 over 5 ain't getting you the same the relationship, right? So directly proportional is division. As one goes up, the other goes up, right? Inversely, which I often say indirectly, which is not accurate. Inversely proportional means as one goes up, the other goes down, and vice versa, right? This is a multiplication relationship. Let me show you why that is. If I have, let's do 5 times 10, that relationship is 50, right? If I increase the 5 to a 25, in order to not change the relationship, what do I have to do to the 10? Make it a 2. One went up, one went down, right? So let's talk about chocolate chip cookies. You've made chocolate chip cookies before. Grace, do you make chocolate chip cookies? Your mom does. And I bet she uses flour, doesn't she? Or she like Ben's parents where they're like gluten-free or whatever? No? Okay, so she's using flour. The more cookies I want, what's going to happen to the flour? I need more flour. So this is directly or inversely proportional? Directly. As one goes up, the other got to go up. So I know if I got 20 cookies and I need 2 3/4 cups of flour, that is directly proportional. That means this, right? That'll always be the same when I increase the cookies. So I'm increasing to 10 dozen. How many cookies are in a dozen? So what's 10 dozen? 120 cookies. And we want to know how much flour do I need? Well, I'm not allowed to change the relationship. So if I times by 6 over 6, that won't change anything, will it? But that'll get me exactly how many cookies I want, which will also get me exactly how much flour I need. Mind-blowing, huh? Let's do 6 times 2. What's that? 12. Good. Let's write that down. But we're not done. What is 6 times 3 over 4? 18 over 4. That's great. That is going to get us 12 plus 16 quarters, which is 4, and 2 more quarters, which is a half. So it looks like 16 and a half cups of flour. Oh, boy. That's a lot of flour, but that's a lot of cookies. Very good. Any questions about that setup? Directly proportional, not allowed to change the relationship, so times by 6 over 6. I'm mowing a lawn, but not mine. Have you seen mine? Oh, my God. 8 people can mow a lawn in just 5 hours. If I increase the number of people mowing, what will happen to the time? This is inversely proportional, so that's a multiplication relationship. So I know people in time is going to be inversely proportional. If I have 8 people, it's 5 hours, right? That is 40 people hours worth of work. What that means is I have 40 hours of a person working needing to be done, right? So if 8 people are working, it'll only take them 5 hours to get this much work done. What we want to know is how many people will it take to get the job done in 4 hours? It's the same amount of work, right? It's still 40 people hours worth of work. That is a real unit, by the way. People times hours is people hours. How many people do we need to get the job done in 4? We need 10 people. 10 people. Yeah, this is like really basic, easy stuff if you know what you're doing. And if that looks like a 20. Really basic stuff if you know what you're doing. But if not, this is like super powerful, interesting stuff that I wish I had taught you guys in Algebra 1, but such is life. We were still busy working on negative numbers. All right, 741, and not roots, which, oh God, regret. A swordfish drives a car at 50 miles per hour for 4 hours. I like including things like this. Christina, the one girl, she thinks this is just like in America, swordfish drive car. I don't know, I think it's funny. A swordfish drives a car at 50 miles per hour for 4 hours. Then it's 60 miles per hour for 2 hours. What is their average speed? Grace, what is average speed? What does average speed mean? Yeah, so it's your total distance over total time. Look at this amateur. It's like she wasn't even in class. All right, so the total distance is not going to be 50 plus 60. We drove 50 miles per hour for 4 hours. So if Grace is on her moped driving at 50 miles per hour for 4 hours, how many miles has she traveled? 200 miles. But that was only the first leg of the journey. Then she speeds up when she's clear of the town. Took her 4 hours to do it. 60 miles per hour in 2 hours is going to be how many miles? 120. Now our total time was 4 hours and 2 hours. So that's definitely 6. So we're going to get 320 over 6. Let's go ahead and divide that up. Looks like 53 and change, right? 6 times 50 gets us 300. 6 times 3 is 18. We get 2 left over, remainder 2. I wish your elementary school teachers, along with mine, would be like, look, don't write R2. You just write 2/6. Because we're talking about 6. So if it's a remainder of 2, it's 2/6. So 53 and 2/6 miles per hour. Yeah, I'm fine with that. Notice that we're going to be between 50 and 60 definitely, right? We drove more 50, so we're going to be closer to 50. That's how averages work. Oh my God. Some of you guys think, so if I do 7s on everything, do I get an A? And it's like, well, 7s don't average to a 90. And you're like, okay, but what if I do 190? And it's like, okay, that's going to average to like a 70-something. Anyway, talking about our students. Alone, Chloe can dig a ditch in 9 hours. All right, studio audience. If Chloe can dig a ditch in 9 hours, how much does she do in 1 hour? 1/9 every hour. This makes sense. If H is 1, she's dug 1/9. If H is 2, she's done 2/9. If H is 9, well, then she's done 9/9. That's the entire ditch. Now, Ember is helping her, and apparently when they work together, instead of it taking 9 hours, it just takes 8. That's not that much help, right? So I don't know how fast Ember is digging, but I know she's digging for the same amount of time as Chloe, and they're going to dig when they combine to one total ditch, right? One total ditch. Now, we do know what H is. If they're digging together, H will be 8. So how much of a ditch will Chloe have dug in 8 hours? Try again. In 8 hours, it'll be 8/9. Which leaves how much? Whoops. Which leaves how much for Ember?
1/9.
This got to be 1/9, right? Right. So what do we know? We know 8 times Ember's speed equals 1/9. How do we solve for I? Divide by 8. We're already dividing by 9. So if we divide by 9 and by 8, we're really dividing by 72. Now, I normally goof and circle this. This is how fast she's digging. The question is, how long does it take her to dig it on her own? It's going to take 72 hours, right? She does 1/72 of a ditch every hour. So it's going to take her 72 hours, which is equal to 3 days, which is why Ember is not much help. Chloe can do it in 9. Ember's literally just like kicking your feet in the ditch, being like, when is this going to be done? I tried to make my problems reflect real life. Yes?
Is it just a coincidence that you could time the 2 hours together? 8 and 9 and 13.
What?
So it says Chloe can dig it in 9 hours.
It's a coincidence. It's a coincidence. It's a coincidence. If I had changed that to together they work in 5 hours, right, that would mean Ember would just be faster. But yeah, you would not get 9 times 5 is 45. Yeah, definitely a coincidence. All right, that's all the basics. It's impossible. This class is too hard. It's just impossible. Chapter 8. Could you, would you in a box? I'm sorry, Huey, what'd you say? He likes this chapter. This is chapter 8, Grace. You remember this one? I know, right? Everybody's like, this is nothing. I told them how hard it was for you guys, and they're like, these guys are bozos. Ooh, Harper went to get friends. Do we want to plot these guys? You want to see this or no?
No. Alright, quiet.
Who are you talking to? Emma's here, and Ember's here. Ember, we just talked about you. Takes you 72 hours to dig a ditch. Before you sit down, if you don't have those already, you might from class. There's all the tests plus a quiz. No, they're all tests. They're all tests, yeah. All those are tests. We're on test 8. We just finished 6 and 7, doing the basics only. We're going to go back and hit the intermediates because that is what the people have requested. The rule is Do not say no if you want to skip a question or say skip. Just say nothing. That way, if someone wants it, they can say yes. This is a much more positive way of doing things. Ember, we're going to count how many times you say no when you're not supposed to say anything. Okay? Does anybody want to do this? Do you guys want to graph these points or? No. Got him. Oh, I'm a master of my craft. Say nothing. You just say nothing. You can just wait for somebody to say yes. If nobody says yes, we'll move on. What about the distance between 2 points? I heard a yes or a please. The distance is Pythagorean theorem, dude, right? We got 2 dots here and here. We want to find the distance. To do that, you got to figure out what A and B are. To do that, we're just going to say the distance between the x's, that's A, right? Horizontal distance. And the distance between the y's, which is B, the vertical distance. So let's find the distance between the y's first. What's the distance between 8 and negative 2? 10. Doesn't matter whether it's negative or positive because distance doesn't care. Slope in the next question do. What about the distance between our x values, between 3 and 5? What's the distance? 2. So we're going to do Pythag. That's a squared plus b squared, right? That'll get us c squared, which is the square of this side. We don't want that. We just want the side, so we're going to root that. Is the answer 12? No. No, you cannot root individual terms. Instead, you get 104, and you root that, which is like a little bit more than 10? Which makes sense, right? We're going up 10 and over 2. It's basically 10. We're basically moving in a straight line. Questions on that? You can say no if you want. This right here, we want to find the slope. Slope cares about direction, right? It's an angle. Okay? It's a rise of a run. It's delta y over delta x. Ah! Chloe, your duck. It's still working, right? Jackson's here. Speaking of Chloe. Where's this picture frame? Did Chloe take it home? How's she going to do her final tomorrow without her picture of Jackson? All right. Everybody get on Snapchat and print out all the pictures that you totally didn't save. All right. Delta y over delta x is what we need. Delta y is our rise. That's our y change. So here are the y values. Ember, y comes after x. So delta y is these two. If we're going from negative 1 to 0, that's a change of what? Plus 1. And if we want to know the change between 9 and negative 7, our delta x, going from 9 to negative 7 is a negative change. Negative what? 16. 9 going to negative 7. Start at 9, walk down to 0, and then walk to negative 7. Isn't that a change of 16? One over negative 16. That's our slope. It's a pretty steep slope. And by steep, I mean it's not actually. 1 over negative 16 is really close to 0. All right. Here, you want to talk about graphing this? All we need is 2 points, because this is a line, right? Can anybody give me a value for x and y that makes this equal negative 18? Negative 6 and 0. And 0, positive 9 will work, right? Are there others? Yes, they're infinite. All of them will be on this line. Negative 6, 0 is here. 1, 2, 3, 4, 5, 6. And 0, positive 9 is here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think this is a great example of stuff that only I have taught you, and you guys seem really good at this. So I'm very proud of that. I'm very proud of that. You guys can graph lines like nobody's business, and you know what it means. So there you go. There's 2 points. All the other points will be on this line. What? Not tapped in right now. What happened? Oh, no. Yeah, I'll go back. Oh, last night? Nah, I stopped watching after the Wolves dropped out. It's too busy this week. I'm a San Antonio guy too, so it's like totally fine if San Antonio wins. I respect that. I'm a Pop guy, so like I've been a San Antonio guy for a while. What's up? By the way, you missed this because you guys walked in late. I am going to scan this and upload it to Classroom, so if you don't want to write anything down, just don't write anything down. It's up to you. I don't care. All right, moving on. We want to graph this point and this slope to make a line. So if you don't know, this point is on our line, so we should probably graph that, right? And -4, 1, 2, 3, 4, 1, 2, 3, +3. Hello, grab some tests over there if you don't have them already. Chloe, did you lose your picture frame?
No, it's at my house.
How are you going to take your final tomorrow without that picture frame?
At least she's being realistic.
All right, we're going to have to print off all the pictures of Jackson and paste them all over the room. All right, so we've got this. -4, 3 is on our line. To find another point, you know that every point on our line is going to be separated by this slope, right? Which one of these is delta y? Correct. No, it is not. He's incorrect. I thought I was asking about delta x. I said the wrong thing. So you read my mind. I was asking about delta x. Delta x is 9. Rise over run. Run is that. So delta x is 9. And what is delta y actually? -1. So if we apply that, we're going to get another point, 5, 2. That'll also be on our line. You could also apply it right here on the graph, though. This means -1 for delta y and +9 for delta x. So if you go 9 to the right, you'll get this. It's a beautiful line. ASMR. All right, moving on. We want to find the midpoint. How do we find the midpoint?
Distance.
It's in the middle. Add total distance, then divide. Just figure out what's in the middle.
Thank you. You could find the distance, cut it in half, and add it back on. That totally works, but there's a way simpler way. It's the average. It's the average location. So what is the average x value? Well, that means we're going to add them up and divide by the number of pieces. There are 2 pieces, so we're going to divide by 2. What's -6 plus 9? 3, and if we divide by 2, we get 3/2. Yes, 1.5 is right in the middle of 9 and -6. I can make you feel more confident with the next one. Let's find the middle of 3 and 7. So that means 10 divided by 2, which is 5. 5 is exactly in the middle of 3 and 7. It's the average location. Those barbecue? What are they? And no dip? Now we want to find the equation in standard form. What form is standard form? Gracie's going to get dog walked on this. Thank you. Yeah, exactly. A and B are kind of your slope. They're not really. Delta y and delta x is going to equal a over b with one of the signs changed. This is just true. We can prove that in a later question if you want. But it is true. So we should find our slope so we can get a and b. Reminder, for standard form, this has to be true. What does this mean? Integers, which means no fractions, right? You can't have fractions for A, B, and C. There's going to be a problem later on where you get fractions the first time you do it, and you have to multiply to get rid of them. If you don't, I'm going to mark it wrong. Not a single one of them heard that. All right. And then we also have this other rule where A has to be greater than 0. What does greater than 0 mean? Not negative. So when we change one of the signs, whatever you have to do to make sure A is not negative, right? Cool. Awesome. Let's find the slope. I'm going down. I'm yelling, Ember. -9 going to 2 is a change of what, Ember? It's not going down, it's going up. Up 11. That's delta y. And then 3 going to -4 is going down, actually, Ember. How much? -7. Very good. So here's our slope, which means our standard form is going to look like this. 11x plus 7y, because we got to change one of the signs, and I'm definitely not changing that to be negative, right? A's got to be positive. Now, how do we figure out what C is? We know these 2 points should work in this equation, right? If they don't, you've got the wrong equation. This is a great way to check if you mess this up. If both points you plug them in and you get different numbers, you done goofed here. So let's plug in both just to be sure. Plug in -4 and 2. What's -4 times 11? Negative 44, and then we're adding 14, which is negative 30. And I'm so confident I'm actually going to write that down. The next 2 points here are also going to get you negative 30. You get 33 minus 63. So we must have the right line. There is but one line that works for 2 points. How are we feeling about that? I want to know, pause for station identification. How's the speed? Too fast, too slow, just right? Too slow. Shut up, Harper. We did that earlier. I threw a bowling pin at her. I'll do it again. Harper! They can't see. All they can do is hear. Yeah. You got hit or got a hit? I don't know. It sounds like he said I got hit. This is Moneyball in this town, right? Why do we like him? He gets on base. All right, cool. Find the slope. Guys, what form is this? If you say standard form, I swear to God.
Oh my God.
93 Michael Jordan. Not White Sox in the spring, but like when he played for the Bulls, okay? All right, you were White Sox Jordan, okay? Slope is negative 3 because, guys, they give it to you for free. M is the slope. M means Monterre. Monterre is French for mountain. Mountain is, of course, the slope. So this is our slope. That's the point of slope-intercept form. Oh, my God. Now we need to find the x-intercept and y-intercept. Now, the y-intercept is on the y-axis. What do all the points on the y-axis have in common? X is 0. So if we know x has to be 0, because look, 0, 1 here, 0, 2, 0, 3, 0, 4, right? If we know x has to be 0, if x has to be 0, what's 0 times negative 3? 0 minus 1 will get you y. What is that? Negative 1. Thank you. Rebound queen over here. Rebound queen. Emma misses and you pick up the rebound. What? Too confusing with chapter 10? I don't know. We need to find the x-intercept. All x-intercepts are on the x-axis. What does everything on the x-axis have in common? 0 for y. No y-ness. Careful how you say it. 1, 0, 2, 0, 3, 0, 4, 0. It's something 0, right? Now, for this one, it's a little bit more complex, so I'm actually going to write it out. If y is 0, we are here. I want you to think. What minus 1 gets you 0? 1. What do you times by negative 3 to get positive 1? Negative 1/3. The negative 3's divide out. You get 1 minus 1. When we graph this, it's going to be really annoying. It's right here. And you're going to draw your line. It's going to be beautiful. Excellent line. 10 out of 10. 10 out of 10. 10 out of 10. Do not forget to find the slope, the x-intercept, and the y-intercept. I will mark the whole thing wrong. All right, guys, we need to find the slope-intercept form. Someone other than 93 Jordan, tell me what slope-intercept form is. Thank you. This is what we're looking for. They told us the slope is 4. So, yeah, right? They give us the x-intercept. That is merely a point. We know that negative 3 should get 0. So whatever b is to make this happen, that's what b's got to be. So, check it out. If x has to be negative 3 to get y equals 0, right now we get negative 12. So what does b have to be then?
12.
It's got to be positive 12. So y equals 4x plus 12 is the equation you are looking for. That's all the basics on 8. Grace's class was crying about this. Oh my God, Mr. Mack. It's so hard. They couldn't do it. They were so bad we had to skip chapter 1, section 8 on roots. And then they're like, what's a cube root? 9. Fam. On 9. It's telling us these two things are true at the same time. And at first it looks contradictory. This says x is greater than or equal to 9. But it's also less than or equal to 9. Well, it definitely can't be greater than or less than at the same time. So it's got to be equal. Now, Landry has this one memorized, which means he gets it wrong on every quiz except this one.
0.
Yeah, that's right. X is the same thing as y. So if x is the same thing as y, x minus y is just going to be 0, right? Because they're the same thing. Just in case you don't want to be like Landry and you want to be able to answer other questions. If this was what I gave you, That means x is the same thing as y, so what do we really get?
0.
Oh my God.
They got a memorized too.
They do. So, fam, pause. This one is 0 because if x and y are the same, anything minus itself is 0. Sometimes, every time, I change this to something else. So if I'd given you this instead, if x and y are the same, well, x and y are interchangeable, right? So why not write that as 5x? That's 8 x's, yes? Yes, okay. For some of you, that's a lot of x's. Others, not so much. Sometimes I put numbers next to that, yeah. I promise you, I literally did today.
It was 0, wasn't it?
No, it was not. All right. We want to know which one's larger. If you have two numbers, one bigger than the other, and you add something to both of them, right? As long as you add the same thing, it's not going to change which one's biggest. Subtracting, multiplying, dividing, etc., right? We're going to do this. We're going to square this. And that's not going to change anything, except it's going to make them both bigger by the same amount. So what we're going to do, it's probably a bad explanation. We're going to square it, and it's not going to change which one was bigger and which one was smaller. If I square this, what do I get?
4 times
The root of 5.
5.
Because the root was affecting both, and we've now gotten rid of that by squaring, right? This will become, by the same reason, 7 root 2. If I square it again, I'm going to get 16 times 5, right? Here I'm going to get what if I square it again?
49 times 2.
And now we can easily compare these. This is less than 100, right? This is 98, and this is going to get us 80. If this is bigger, well, then it must have been bigger to begin with. All right, pop quiz. What is bigger, 1/2 or 1/9? 1/2. 1/2 is bigger. Smaller number on bottom, bigger number overall, right? So we want the smallest bottom. This is like 2002 Slim Fast. So this right here, we have 4 plus 6 plus 8, blah, blah, blah. We're going up by 2s, yeah? Notice that all of this is here up through 96, or up through 98. This one just adds on 100 plus 102. So which bottom is bigger? The one on the right. Do we want a big bottom? No, it is 2001 Slim Fast in here. We're not body positive, apparently. So if we don't want a big bottom, this one is going to be the biggest number overall. Smaller bottom, bigger number. There you go. For each of the following inequalities, graph the inequality on a number line and write the solution using interval notation. This is a compound inequality. Let's subtract 1 from everything. We get -6 less than or equal to 3x less than or equal to 6. The reason I did this is because I'm trying to get x on its own so I can see how x relates. I know how 3x plus 1 relates. I now know how 3x relates. But what I want is x. What do I need to do to get x on its own? Divide by 3 to everything. When you do this, do you need to flip the signs? When do you flip the signs? Multiply or divide by a negative because it's going to change the order of the numbers if you don't otherwise, right? So this is saying I've got between -2 and +2. So Grace, this is a chapter we didn't do that. I really wish we did because you guys suck at this stuff in Algebra 2. This right here, x can be -2, x can be +2. See how it's less than 2, but it's also greater than -2? It's in between them, right? There's a little graph. Let's write the interval notation. X exists between, at smallest it can be what? And it can literally be -2, which is why we're using that square bracket. If this was an open circle, if this did not have a line underneath it, we'd use open circle and we'd use a curved bracket. And what's the greatest it can be? 2, and we're going to use another curved bracket, or a square bracket. Not always are they the same. If that didn't have a line underneath and this did, one would be closed and one would be open. There you go. There you go. Pausing for station identification. How we doing? Yeah. Okay.
Wait, this map. Can you make a half circle or not colored circle?
Half circle? You mean open circle? Open circle is if there is no line underneath because it's not allowed to be equal to. So you would do open circles between 2 and -2, and you would do brackets like this here. Mm-hmm. Negative infinity and positive infinity, by the way, always this, because they're not numbers, right? Negative infinity, positive infinity ain't numbers. All right, turn the page. We got one more page for basics on 9. And it is only 6:53. We've only been doing this for like 40 minutes. Nice job, guys. At the end of January 2005, the population of my town was 9,444. We are increasing it by 162 every month. It is booming. This is like pre-2008 crash. All right, literally these are the numbers that my town had. So anyway, in what months does the population exceed 13,000? That means this, right? Now, this seems hard to think about, but it'll be easier when we get all of our stuff together, right? Collect all our terms. If I subtract 944, guys, let's do this in our heads. What is 13,000 minus 9,000? 4,000. If we take away 400, we're at 5,000. 600, 5,600. If we take away 40, we're at 5,560. If we take away 4, we're at 4,550. 4,556. That is not right. 3,556. All right. We need to know how many times 162 goes into this. If we take 162 times 10, don't we get 1620? What? Is it actually 22? That's 3240, right? So that's 20 times. We're pretty darn close. How far are we away? Looks like 316. So if we do 2 more of those, we win, right? So that's 10 here, and 2 more is going to get us 22 months. So 22 months from January 2005 is 2 months short of a full year, right? So what's 2 months before January? November. Very good. Very good. You got your December. You got your November. Okay. It's at the end of January. So a month ahead would put us in February. 12 months ahead would put us in January again, right?
I got October.
All right, hold on. We're probably counting the first number twice, which is probably the issue. So let me double check. I might have made a mistake. So February, right? March, April, May, June, July, August, September, October, November, December is 12 months, right? Or that 11 months. So 12 months is January. Yeah, so 12 months is January. And then 10 more months is going to be 2 before. It's November.
It is October. And I got it wrong in the test.
Pause. If I'm at the end of January and I go 1 month ahead, I'm at February, right? March, April, May, June, July, August, September, October, November, December, January. That's 12 months, right? Then we do 10 more. February, March, April, May, June, July. But you're starting in February. February, March, April, May, June, July, August, September, October, November. I win. All right, fam, this next one. It wants to know when x minus 2y is equal to 6 and when it's greater than. If I gave you this, if I just focused on the equal, what would this look like? Yeah, it's going to be a line, right? So let's graph where it's equal. Can anybody give me 2 points that are going to make it equal? 0, -3, and 0, 0 would not work. 8, 0 would not work. 6, 0. 8, 1 would have worked. Yep. 0, -3, 6, 0. 1, 2, 3, 4, 5, 6. This represents where it's equal. But that's not all we want, right? We also want where it's greater than. So here's what we do. The easiest method is this. Pick a point that's not on the line, because if it's on the line, it's going to be equal, right? I'm going to pick 0, 0. It's not on the line. If 0, 0 makes this true, then that must be where the greater side is. If it doesn't, then we're going to shade the other. Do not assume that the greater is always above. It is not always that way. If you plug in 0, 0, you get 0 greater than 6. Is 0 greater than 6? No. Here's a prime example. The above, that many people would call this, was not actually the greater portion. So this is where it's equal to, this is where it's greater than, this is where it's greater than or equal to. Questions on that? That's it for 9. We're moving on to 10. This is where like Algebra 2 basically started their year this year. They thought this was so hard. All right. Guys, the first 2 questions like really trip people up. In fact, the first 3. because they're so different than what we've been doing the most of the chapter, but they are kind of the same idea. First off, let's make this equation easier to work with. How can we make it easier to work with? Get rid of fractions, right? If we multiply by -5, don't we get this? All right, now turn your brain on. What do you times by itself to get 25? There are two, count them, two answers. Either of these will work, right? If you times -5 by itself, don't you get positive 25? Negative times a negative is a positive, unless we're talking about imaginary numbers. Not yet. They're like one chapter away from doing two chapters away. You guys did 10 to start the year. You did like you guys started in 8 and then went to 10. Yeah. And they're cooking on 8, as you saw. All right. This guy. It's really obvious once you see the answers, but if you don't know them, here's what you're gonna do. Rewrite this so it's in standard form of a quadratic, right? Ax squared plus bx plus c. What common factor do they both have? If we take out an r, we get this, and now it's obvious what the answers are. What's one of them? -13, because -13 times 0 is 0, and the other answer is 0 because 0 times 13 is 0. I want you to look at this so you can see why that makes sense. Do you see how -13 times -13 is equal to -13 squared? Yeah, that's what it means to square. And then the other one is 0 times -13 equals 0 times 0. Is 13 an answer? It can't be, and here's why. 13 times 13 does not equal -13 times 13, right? It's not. So these are the answers. It's not plus and minus. All right, look at 1014. 1014. 70 times my number. So here's my number, m or something, is equal to the square of my number divided by 5. How can we make this easier to solve? Get rid of fractions, right? Times by 5. It is an equation after all. And this is what we get. Doesn't this look a lot like 1012? It does. Let's rearrange this so it's obvious what our answers are. After we subtract 350m, we get this. What common factor do they both have? M. Pause. I want to talk about this. This is a super common mistake. Everybody says, ooh, let's just divide by m. And what we do is we get m minus 350 equals 0. That means 350 is our answer. We have removed one of our answers by doing this because we accidentally divided by a number we're not allowed to divide by. When we divided by m, we secretly divided by what?
0.
We did. We divided by 0. And you're not allowed to divide by 0, right? Whenever you divide by a variable, you have to ask yourself, is that variable secretly 0? If it is, you can't do it. And that is the case here. 0 is another answer, right? So you cannot divide out. You must factor out. And now you can clearly see that, yes, one of the answers is 350. But in this case, we're going to get BOFA. The other one is 0. Questions so far? All right, this one. First, rearrange it so it's in standard form. Your quadratic term first. Make sure your quadratic is always positive, right? It's no negative in front of here. If it was, I'd move it to the other side. And then your linear term next, and then your constant after that. Now we've got it equaling 0. This is going to be a much easier question if we turn it into multiplication. Something times something equals 0. This is called factoring, and as Grace will tell you, you never use it after the end of Algebra 1. It never comes up ever again. Factoring? No, you never use it. You might as well just forget it, right? That's a joke. Factoring is like everything you do beyond Algebra 1 forever and ever and ever. Please get good at this. Do not be like Christina Andrews, who's just like, I'll just use Ukrainian method. And I'm like, what's that? And it's a quadratic formula. And I'm like, girl, you take 10 years to solve x squared plus 2x plus 1 equals 0, and you got it wrong. And not only that, you're not going to be able to do any of the stuff we do in Algebra 2 where you got to like factor stuff and figure out, plus minus with the inequalities. Oh, God, what a disaster. All right, anyway, what do we know for sure this is going to factor to?
0.
TNT dynamite. You see, if we distribute, we get back to t squared. Now, fun fact, whatever you put here and put here isn't going to have a t in it. And it will distribute back to what number? 18. -18. Fam, if we know we're going to multiply to a negative, what does that mean? It's got to be negative positive. We're doing t-ball right now. Please bear with me, because when we get to the intermediate, you're going to get your butt kicked. What negative and positive number multiply to 18, but also add the -3?
-6.
-6, and +3. Notice if we distribute here, we're going to end up with -6t's, +3t's. That's going to be a -3t's in total. This is the same question as this, but this is easy to solve. Who can tell me one answer that's going to make this equal 0? -3 is one of them. And the other is 6. It is not 6, 7. -3 is an answer because when we plug in -3, this becomes 0, this becomes -9. 0 times anything is 0. The other answer is 6 because when we plug in 6, we get 0 times 9, which is 0. And that'll be the same answers to this question and this question because they're the same problem. Here, we need to rearrange this. Should I subtract x squared over? No, that'll make it negative. We always want our leading coefficient to be positive. So move everything else over by adding and subtracting. We need numbers here. Guys, I need numbers that multiply here and here to something without an x in it. What doesn't have an x? 36. 36 is positive, so we have options. Our options either are double positive, positive times positive is positive, or double negative, because that also gets you a positive when you multiply. Which is going to be? Double negative. Because they will never, ever, ever add to -15 if they're both positive, right? And they got to add to -15. A total of -15 x's. Now, what things multiply to 36 and add to 15? It's 12 and 3, right? 12 times 3 is 36. -12 and -3 adds to -15. How are we feeling about the numbers here got to multiply to that? And after they distribute, they're going to get us a total of this many x's. Yeah, good? Okay. What's one of our answers? 12, other one's 3. Turning the page. Somebody crapped on my floor? That's not good. Andy took the day off today. He's home resting. So he can't even clean this room. But luckily, you're going to pick it up so he won't have to no matter what. Yes. I mean, I don't know. Is it literal crap?
No. No, it's a bunch of like grades.
Okay. No, after the final? God, no. No. Fam, no. We are done with that as of right now. Okay. Find the sum of the roots. So the roots are the answers, right? So like, let's flip back to this one real quick. The sum of the roots here would be 3, right? And the product would be -18. You notice something about those numbers? They're related to this, right? So we proved in class, and we're going to prove later on in intermediate, so I won't do it right now, that the sum of the roots will always equal, whenever you add them up, -b over a. And what I mean by that is if your quadratic looks like this, that's standard form of a quadratic, right? Your roots will always add up to the negative version of this over a. It's just true. We proved it in class, and we'll prove it again when we get to the intermediate. But this is true. So if we want the sum of the roots, we could factor this, find our answers, and add them up. But you know what's way faster? Just doing -b over a, which is -5 over 1. Isn't that just -5? There's the sum of our answers. Now the product of our roots, on the other hand, let's grab a pen that's a different color. The product of our roots, on the other hand, will always equal c over a. This is true. You could find your answers by factoring and then times them together. You're going to get -176. It's true. C over a. This is C, this is B. -b over a is your sum. C over a is the product.
That makes sense.
It does, and we proved it in class. It makes even more sense when you prove it. All right, everybody gets stumped on this one, which is very funny because this is super easy to factor. Imagine we tried factoring without raising our hands and crying first, okay? What will we need here and here? X and X. Now, we know we're multiplying to a negative. What does that mean?
One negative.
One negative, one positive. And how are we going to get m squared? It's got to be m and m. Wicca, wicca. All right. Now, if you check, this will work because when you distribute, you get x squared. If you distribute here, you get x times -m. What is x times -m? -mx. That looks scary because that's not part of it, right? But wait, there's more. What's m when we distribute it here? What's m times x? Hey, look, conjugates have their middles go away. And this doesn't have a middle, does it? M times M will then get you M squared, but of course it's negative because one was positive, one was minus. Hey, look, it does work, doesn't it? Here's your answer. Boom. We call this the difference of squares because it's a difference, minus sign, of squares. Two things being squared. Always factors to conjugates. That's it for the basics. It is Harper time. Do we want to do the intermediates on 10 and work backwards or go...
Yeah. No. Yes. Please.
Yeah.
Yes.
All right, pause. Pause. Here's what I want you to do. I want you to think about which quiz you want to start out for the intermediates for, okay? Think about it. I'm going to be back in a little bit. Don't say anything that's going to get me banned off of YouTube. I cannot go to kick, okay? No, but thank you.
Oh, he's going to buy some drinks. 6, 7.
All right. I need you guys to figure this out. 6 or 10 for intermediates. Raise your hand if you want 6 intermediates. Raise your hand if you want to start with 10. Ooh, it's a tie. Tie goes to the runner. Tie goes to the runner. 6. I want Harper to go away as soon as possible. So we're going to do which one? 6. I want Harper to go away as soon as possible. Harper, why couldn't you have watched the video from the other night? We did all of these. Why didn't you just watch the video from the other night? We did all of these with the 8th graders. All right, I've changed my mind. Harper, you can watch that video if you're really that impatient. We're going to do 10 intermediates, and then we'll do 6. Then we'll do 6, okay? 6 takes 10 years to do. All right, so fun fact. We should probably rearrange this to standard form, where we have the quadratic term first, then our linear term, then our constant. Now, we pray to God that all of these are divisible by 3. Unfortunately, they are not. So we're stuck with this 3 here. Now, we need numbers that multiply to 147 here and here, right? Yikes. Did you know 3 times 50 is going to get you 150? So isn't 3 times 49 going to get you 147? Right? Now, maybe that's right, maybe that's wrong. I don't know. We might have to list out some other ones, right? But think about it. Think about it. If I have 3 times... Oh, but hold on. Wait a minute. No, because that 3 here is going to screw everything up, isn't it? I was thinking 3 and 49 makes 52. But this 3 here is going to triple whatever we put here, and that's going to screw everything up. Let's mess around with some more of them. Let's list our factors of 147. Obviously this. It might be. Does 2 go into 147? Nah, it ain't even. 3 does. Does 4? No, if 2 doesn't, then 4 won't, then 6 won't, then 8 won't, then 10 won't. None of those will work. So what about 5?
No.
Nah, it goes to 150. What about 6? That's even. No. What about 7?
No.
It does. This is 7 times 7 times 3. 7 times 7 times 3. So it's 7 times 21. That'll be 42, 63. Yeah, that's a bummer. And that's it, right? Because then the next one's 21. Yeah, next one's 21. I think this is unfactorable, right? Because if we put a 7 here, we get 21, and 21 here gets us 42. Maybe that was supposed to be a 4. That might have supposed to have been a 4. This is unfactorable.
Yeah, let's put that one on the.
This is always an option. It's unfactorable. Now, this one right here. What makes this one tough?
Well, your phone did not turn out smoothly.
Hey, yo. I'm doing all these because you guys said you wanted to do them and you're not even paying attention. What makes this one weird? What can we do to make it easier? You could.
Times by 2.
This is 15 halves, and this is 13 halves. So timesing by 2 would be a great idea, wouldn't it? Now, we're stuck with that 2t squared, yeah? So we definitely need t and t, but what's the only way to make 2? 2 and 1, right? Now, we still need numbers here and here that are going to multiply to 13, right? What's the only way to multiply to 13? 1 and 13, right? 13 and 1. Do we want positive or double negative?
Double negative.
No, yeah, double negative.
Where do I want the 13 to go?
Wait, this one's tough.
Hey, yo, guys, this is tough, and if you pay attention, it's really easy.
13 and
If we put the 13 here, do you see how we're going to double that 13 before we add them up? We do not want that. So I'm going to put the 13 here and the 1 there. That way when I get this, I get negative 2 t's, and I get negative 13 t's for a total of negative 15 t's. So this doesn't care about these two, right? That's still going to get you 13. What it does care about is when you're getting your t's, right? Cool. So now we're going to say when this equals 0. Do not tell me one of the answers is 13. It's not. It's 13 over 2 or 7.5. And the other answer is 1.
you would make a good math teacher.
It's almost like
That's what I've been saying.
Yes, you may.
All right. 10-4. The sum of the roots of a quadratic is negative 15, and the product is this. Guys, what do we know about the sum of the roots? It's always what? Hey, is this... You're going home right now?
Yeah, you told me to watch the video.
You could if you're impatient, but you can stay too. Oh no, Harper. Negative b over a is the sum of the roots. Hey, negative b over a is the sum. Yeah, divide out the a from everything, right? The product of the roots is always what? So check it out. If we know the sum, this part is equal to negative 15, and we know that the product is equal to negative 76, is it conceivable that a is just 1? Right, a could just be 1, and if a is 1, so if a is 1, that means negative b is negative 15, so what is positive b? 15, right? If you plug in 15, you get negative 15. And if a is 1, what does c have to be then? Very good. Which means we now have our quadratic. X squared plus 15x minus 76 is our quadratic. Now it says find the roots. We have to factor this. I have a feeling this is unfactorable. Mr. Mack, what are you doing? It might be, it might not. I don't know. Let's prove that it is. If I know I need numbers that multiply to a negative 76, what does that tell us? 1 negative, 1 positive. Always start with what you know is true so that you have less things to think about, right? So we already got this locked in. It's got to be that. We probably want we definitely want the positive to be bigger. That way we get positive 15, right? So what numbers multiply to 76 and add to 15? No. Let's write them all out. Definitely not this one, but it's always good to write it. Does 2 go into 76? Yep, and if one of them is negative, we don't get 15, right? Either we get negative 36 or we get negative or positive 36. Does 3 go into 76? How do you know? It's going to go to 60, so it's going to go into 67, right? Or 57. 4, does it go into 76?
Yes.
This is 2 times 2 times 19, right? So it's 4 and 19. Hey, guess what? That's what we want, right? Positive 19 minus 4 is 15. Use what you know to figure out what you don't know. 2 times 2 times 19. 4 times 19. Our answers then, our roots, are going to be negative 19 and positive 4. You have to give me that answer. Don't just write this and be like, I'm done. A lot of you guys do that. All right, take a look at these guys. I wish everything was divisible by 13. That'd make life good, right? But they're not. So I guess I'm stuck with it. Good news is that 13 is a really nice number because there's only one way to make it when you're multiplying. 1 and 13. So it's got to be 13R and R. I did not leave myself enough room for that one. That'll be okay. Fam, I know what about the signs?
It's positive.
Positive, negative, because they got to multiply to negative 15, right? So we got one of each. I probably want the plus sign here and the minus sign there. That way I times this by 13 to make it a big positive number and subtract this to get 34, right? I probably want this. I could be wrong, but we're going to find out. 15, it's either 15 and 1 or 3 and 5. I think we're going to want 3 and 5, right? 39. Oh, yeah. What? 3 goes here, yeah? So we get 39 R's. And if I put a 5 here, that gets me minus 5 R's. That's 34 R's. So this gets me negative 15. That's why I chose 5 and 3. But that's going to get me positive 39 R's minus 5 R's. That's 34 R's. All day, every day. Your answers are definitely negative 3, but not 5. What's 5? What's the answer over here? These divide out, you get 5 minus 5. The goal is to eliminate as much guessing as possible. That way you can try things out in your brain. Definitely take care of your negative positive first, all that jazz, right? Over here, what can we do to make this problem easier to work with? How can we do it? We need a number that'll divide out 6 and 2. The smallest number I can think of is 6, right? Okay. So now, here's the bad news. You know how 13, there's only one way to do it? Isn't 6, 6 and 1, but also 3 and 2? Yeah. Here's my thought. If it's 3 and 2, and we need plus minus, we need 11, which is a pretty big number. Let's just rule out 6 and 1 first. Let's try 6 and 1. At the end of the day, there is a bit of guessing and checking here. We know it's plus minus. I probably want the plus over here, minus over there to get a big positive number, right? 21 is 7 and 3. If I put a 7 here, I get 42 minus 3. That ain't it. If I put a 3 here, I get 18 minus 7. Nailed it. So 3 here, 7 there. So check it out. This is negative 21, right? This is 6t squared. But notice this is what's going to get us 18t's minus 7t's, which is 11t's. That means one of our answers will be negative 3. What's the other one? It's not 6 over 7. It's 7/6. If you are trying to learn today, it's going to be really tough. Learning takes time. Understanding takes time. If you're reviewing, you're probably feeling really good right now because you learned it before, you put in the time before. There is still hope to learn things in a short amount of time, though, but you have to set modest goals, right? If you're learning new things today because you never learned it before, fantastic, congratulations, but don't expect it to stick. Don't be disappointed when it doesn't. Focus on just the small stuff. The way I would study for this is I'd do 2 days worth of studying. Congratulations, you have less than 24 hours. First thing I would do is study all the stuff I definitely know to make sure that I'm not going to miss those. And then the second thing I'd do is pick a couple of things to try and learn. That way you can get better, right? Some of you guys have that luxury because you're like, yeah, my grade's pretty fine. Other you guys, you kind of have to learn a bunch of new things in very little time. I'm sorry, right? That's what the whole semester was for. Hopefully we've learned some lessons and we'll be better off in the future. That's my whole goal. I want you guys to be better off in the future. I can't control your past, can't control your present, but I can help your future. Over here, we want to know, when will this equal 0? What will we have to plug in for x to make this equal 0? 0 times a plus b gets us b. That's not 0 necessarily. Grace is right. Let's see if you can understand why. If I plug in negative b over a, I get a divides that with this, and I get negative b plus b. Isn't that 0? What's our other answer? Grace? No. Negative d over c. So the c's divide out and you get negative d plus d is 0. It's just pointing out this pattern that we always do, right? You guys have known this a lot longer than this. All right, this guy. Find the product of the roots of the equation. Isn't the product always C over A? So it looks like negative 704 over negative or positive 96. Circle it, move on, who cares? C over A. All right, this right here. Fun fact, I chose random numbers for this, and I'm pretty sure this is going to be unfactorable. However, here's the strat. First thing we're going to do, really dangerous, really dangerous, really dangerous, really dangerous. We're going to square everything. Now, do you see how there's two terms here? Do you see how there's two terms? You cannot square individual terms. You do not get 9 minus x squared. That is not how that works. When you square this, you definitely get 7x minus 4. That was the point, right? But when you square this, you have to treat it like it's one term. You use parentheses for that, right? That's what we get. And you might think, okay, now distribute. No, you cannot square individual terms. What does it mean to square something?
Multiply by itself.
If you write it out, you won't make this mistake. Guys, we're going to have to distribute, right? Yes. What is 3 times 3? We're also going to get negative 3x, aren't we? Notice because we're squaring, we're going to get the same thing in the middle again, negative 3x again when we distribute that negative x. And we're going to get negative x times negative x, which is positive x squared. Now, danger, warning, danger. Do you see how we have an x squared? Gauss says there must be two answers to this question then, right? Sometimes it's literally the same answer twice, right? Gauss didn't say they have to be different numbers. They just have to be two numbers. But here's the problem. Was there a square in the original? No, so this implies there should only be one answer. What is going to happen here is you're going to get two answers. You need to check them both. One or more of them could end up being false solutions. They call those extraneous solutions. And that happened because we introduced this square that wasn't there before, right? We inverse this, and you can get multiple outputs, right? So there's a problem with that. So what we're going to do is we're going to rearrange this, and we're going to try and solve for x. So when we do this, I'm going to get all my x's together over here first, I guess. So we have 4x minus 7 equals, I'm going to write x squared minus 6x plus 9 because it just bothers me when they're not in standard form. And after I move everything over, I'm going to get this, x squared minus 10x's plus 16. Let's go ahead and factor this if we can. Maybe it is, maybe it isn't. What numbers multiply to 16 and add the negative 10? Well, we definitely need either double plus or double minus. Which is it? Do you see how it's double minus? Those will multiply to a positive, right? But so would double plus, right? That would multiply to a plus, right? But they would have never added to a negative. So it's got to be double negative. What numbers are going to multiply to 16 and add to 10? 8 and 2. 4x minus 7? No, it's not. I switched the numbers. I literally did. Everybody cross out 7x minus 4 and write 4x minus 7. Because it's actually going to work out in this way. Pretend it's 4x minus 7. Yeah, there we go. That one is. Okay. Okay. So, fam, this actually works out because now we have our two answers, 8 and 2. But here's the thing. At least one of these is an extraneous answer. Has to be. Because we shouldn't get two answers for this thing, right? So here's what you got to do. You got to go back and plug them into the original problem and see which one doesn't work. Whoa. Let's plug in 8. What is 4 times 8? 32 minus 7 is 25. What's the root of 25? 5. And then we get 3 minus 8. What is 3 minus 8? Negative 5. So it didn't work, did it? Extraneous. Now let's try 2. What's 4 times 2? 8 minus 7. What's the root of 1? 1. And then we do 3 minus 2. Right? Hey, that worked, didn't it? That's a real solution. I must have switched the 7 and the 4 a while ago, and I unswitched them just now. That's convenient. All right, if the sides of a square are each increased by 8 inches, guys, look at this. Here's my little square. I'm going to call it x by x. What is the area of that square? X squared. That's why I call it squaring. And apparently I've increased the sides. Okay, cool. How much did I increase the sides by? So, don't answer this, Grace. What will my sides be now if I added on 8?
X squared plus 8.
x plus 8. I'm adding onto the sides, not adding onto the area. Now, the area got bigger by 144, so it used to be x squared. Now it is x squared plus 144. So here's what we know. We know these should multiply to equal this, right? So let's set that up. X plus 8 times x plus 8 should equal x squared plus 144. Let's solve for x, right? That'll be the original side lengths. To do so, we're going to have to distribute x times x is x squared. This is going to get us 8x's twice. That's 16x. And we're going to get 64, right? Hi, Billy. Now, after we get here, what's going to happen when we get all our stuff together? X squareds are going to go away when we subtract that x squared over, right? So we're going to end up here. 16x plus 64 equals 144. That's good. Now we're only going to get one answer. And that makes sense, right? There should only be one answer. All right, so after subtracting x squared, that's gone, right? Turns out they both go away. That's nice. If I divide by 16 right now, I'm going to get this. All right, sorry. If I divide by 16, it's going to make my life a lot easier. Some of you would subtract 64 first. That's fine. But I just noticed all these are divisible by 16, right? 16 times 9 is 144. You guys see that? 12 times 12? Yeah, crazy, huh? So this means x has to be what?
5.
The original side length was 5. So this got to equal that. Okay, cool. Distribute, distribute, distribute. Subtract. Hey, the x squares went away. And then here I divided by 16 because it would just make the math a lot easier. That's it for the intermediates on 10. If you're feeling like a little on that, that's because, well, we only spent like a week and a half on it, and it's meant to be a preview of Algebra 2 to prepare you better for it. And I think you guys will be. You guys are really good at factoring when there's nothing in front of x squared, and you're okay at factoring when there is something in front of it. So I think you guys are really going to be well equipped for that. So what do we think? Should we go do 6 for Harper? Or should we do something else? Harper, if you're watching right now, although she's not because it's not live. I couldn't get to work on the live stream. Harper, if you're watching right now and it's not live, I will definitely do all of the 6s at the end, even though they're already in the other video. So even if when we get done at 9 or if we get done early, I will do that for you because you're the only one that wants them. So we want to do 7. Is that what I'm hearing? I'm not taking him seriously. We want to do intermediates from 6, 7, 8, or 9. Raise your hand if you want 6 intermediates. All right, sorry, Harper. 7 intermediate. Okay, that's 3 of them. 8 intermediate. Wow. Okay, 9 intermediate. All right, cool. So it sounds like 7 and then 9. Well, 7 is literally 2 pages, so it's a little bit faster. So 6 takes a while to do, which is why I'll do it at the end if we need it. All right, some deep knowledge. This is not on the final, so we're just going to skip it. It takes a really long time, and it's not that hard. It just takes a long time. Oh. The what one? Yeah, I told them on the video that I didn't put that on there. Now, your final is different. I want to make it very clear. Your final is different than the 8th grade. So do not assume the same questions are on there. Neither of those are on there, and I did change the numbers. We had somebody a couple years ago that thought, oh, you didn't change the numbers, and they tried to cheat, and it was so bad because they got every question wrong. If they had actually used their brain, they would have got some of them right. It would have been better. It was really bad. It was really bad, right? So I try to say that they're not the same. That way you don't make that same mistake, okay? Be honest, but, like, if you're not going to be honest, at least be smart. So there you go. Okay. So x and y are inversely proportional. What does inversely proportional mean? Timesing or dividing? One goes up, one goes down. That's a timesing relationship. 50 times 2 equals 100. 25 times 4 equals 100, right? As one goes up, the other goes down. So x and y are inversely proportional, and y and z are directly proportional. That means this, right? They said when x is 5, y has to be 6. Okay? And when y is 6, apparently, z is 3. They want to know, what is x when z is 6? So this is their question, right? So fam, what does y have to be if z is 6? If z is 6, this got to be 12, right? 6 over 3 equals 12 over 6. So that means y is 12. That means y is 12. Notice this is 60, right? So x ain't going to be 10. What's going to be? This is inversely proportional, dude. 60. X got to be what? X got to be 5. 5 times 6 is 30, dude. My bad. 5 times 6 is 30. So x got to be what? 30 over 12. There we go. 30 over 12. X and y are inversely proportional. So as one goes up, the other got to go down, right? So we're going down. Notice this is 30. That's the relationship between x and y. So when y is 12, x still got to make this equal 30. What times 12 is 30? 30 over 12 is less than 5. It did go down. So again, z we knew had to be 6. So y would have to be 12, right? And if y got to be 12, then x got to be 30 over 12. I think I've said that this is 60 multiple times now. It's actually 30, right? 5 times 6. Turning the page, we got two more. Just because I look like a burnt chicken nugget. All right, 20 chickens eat 8 bags of scratch in 5 days. All right, guys, think. If I increase the number of chickens, what's going to happen to the number of food that I need? It's going to go up, right? I need more food to keep the balance. So that means chickens and bags are going to be directly proportional. That is this type of relationship, okay? Now, what about the chickens to the number of days? The more chickens I have, what's going to happen to the amount of time? It's going to go down because I'm going to have less time with the same amount of bags, right? They're going to go through it faster. So that means it's directly proportional. Oh, look at that.
I just brought pizza.
Oh, you got me pizza!
The pizza is here.
I got cheese for you.
Oh, that's very nice of you. Thank you. All right, so fam, that means we have this type of relationship. We can only write this, though, if we also know days and bags are directly proportional. If I have more bags, will they be able to eat for longer? Yes. So this is all true, no matter how you slice it. This is exactly how the relationship is. We know 20 chickens with 8 bags gets you 5 days, right? So what happens? How long will it be if we have 9 chickens and 30 bags? How many days will that be?
Yeah, just don't do this.
I simplified this. Let's solve for D. Simplifying this down, let's solve for D. I can simplify it further. This is going to be, they both have a factor 4, so 25 over 2. Wouldn't I times this by 5 over 5? I mean, you got options. You can think 125 equals this, and you divide by 3. You can do that. That's totally fine. But if you just times by 10, this is going to get you 25 times 5, which is 125, equals 3D. Right? Times by 10, you get 250 over 2, which is 125. And if you divide by 3, you get the number of days, 125 over 3. Yep, it's... Oh, boy. Are you okay, Billy? We'll take that as a yes. All right. Bart is writing lines on a chalkboard. So remember how Ember and Chloe were working together, where Ember was like, taking 72 hours to get the job done? Bart is actually working against Nelson. So they're not going to add together to get one chalkboard. They're going to subtract to one chalkboard, right? So Bart takes 20 minutes to cover a whole board. How much is he covering in 1 minute? 1/20th of the board, right? Every hour, or every minute, I should say. If he's done it for 1 minute, he's covered a 20th. 2 minutes, he's covered 2/20th. 20 minutes, he's done the whole thing, 20/20th, right? Now, Nelson is working against him. So he's subtracting from the board. It takes him 30 minutes to erase. I have no idea how it takes longer to erase than to write, but it does. It takes 30 minutes to erase. So in 1 minute, how much does Nelson erase? He erases 1/30th. That is why it is negative, and he's going to be working the same amount of time as Bart. They are working simultaneously. Together, we want to know, when will we get one entire board? If it was just Bart, well, 20, right? 20 minutes, he's got it, right? So when will this happen? What makes this problem hard? We got fractions. How can we get rid of them? Or get common denominators. I'd probably multiply since it's an equation. What can you times by that is divisible by 20 and 30? 10 is not divisible by 20 or 30. 60. So if we do 60 divided by 20 times 1, don't you get 3? If you do 60 divided by 30 times -1, you get -2. Hey, look at that. Isn't m equal to 60? It takes him exactly an hour. What do you know?
You have brain cells. Such an amazing revelation.
Emma, is there anything else that you need before you go? That's it? Okay. What about you, Imber? All right, later. I got it for you? Yeah. Cool. All right. That was 7. Do we want to go to 9 now? Jaden wants 9.
I'm not gonna eat. It's fine. Have one of my theoretical slices. I'm not gonna eat the pizza.
Because you had that Chipotle.
The only thing I want is a singular breadstick, and that's it. I do not care.
Landry, you ate both of those?
Who? Really? Mr. Matt, you want to slice?
I love
That is very nice of you. I might have one.
Who breaks one of them?
Could break the other one.
A.B. Jackson.
Thank you, Jackson. Thank you so much.
Wait, where's your camera? Aw, why?
All right, I hear it.
And we were like, oh my god, it was like an inch away from him. And he threw a basketball at us, and he missed every single one of us.
You want to come that one? Well, he's taking my new bell.
Oh, good. I thought it was you. Okay. Yeah.
She didn't take a tumble?
No, she said it was a garbage can.
Take a tumble. To burp. Good pizza.
Around here, I agree.
Hey, Matt, what's your
You
favorite?
would.
Crystal, whoa!
What's your favorite pizza place? I'm on it.
Ever? Okay. Aurelio's in Chicago, probably. Giordano's all right. Yeah.
But
My favorite pizza, because they actually like kind of stuff I can eat kind of regularly, is the Pizza Ranch pizza.
Pizza Ranch is all right.
No,
What?
Little Caesars is the way to go.
It'll get you through it.
It's hot and ready.
I love me some Little Caesars.
All right, fam. Talking about these intermediates on 9. First off, x and y are negative. That's what this means, right? Your entire job is to take what you are given and make it look just like this. So we're definitely going to need to divide by x and y, right? So go ahead and start with this. We know x is less than y. Cool. Let's divide by x and y, right? I mean, that's going to get us closer to this, right? If I divide by x, this becomes 1, right? If I divide by x, this becomes y over x. So I've got x on the bottom. That's at least a good start. Now, I didn't write the sign because what's going to happen when I divide by x? What happens? It changes the sign because we divided by a negative number. X and y are negative, right? They're less than 0. There you go. X and Y are less than 0, so they're negative. You divide it by X, so you divide it by a negative number, it's going to change sign. Now, let's go ahead and divide by Y to get Y on the bottom, right? That gets us 1 over Y. When we divide this by Y, what's Y divided by Y?
Y, R0.
1. So we get 1 over X. Now, what's going to happen to the sign? I just divided by a negative. It's going to flip it back. And at this point, I always say, oh man, I wrote the thing wrong because I'm not reading it correctly. This looks like the opposite of that, right? But it ain't. 1 over X is greater than 1 over Y. That's exactly what we wanted, right? So we proved it. 1 over X is greater than 1 over Y. We did it. 1 over X is greater than 1 over Y. That's what this says, right? 1 over X is greater than 1 over Y. That's what we wanted. Yeah, it's just flipped. Yeah. All right, which number is larger? This is kind of cool, right? We can't just square them both, because squaring it will get rid of this root, but it won't get rid of the cube root. We also can't square this and cube that, because that could upset which one was biggest, right? So here's what we're going to do. Grace doesn't know any of this, because her class noped out of this section. Hey,
Whoa, whoa, whoa.
they're much better now, and I'm very proud of them. So this is 5 cube root 2 all to the half power. That's what square root means, half power, right? This is 2 root 6 all to the 1/3 power, okay? So again, we can't square this and cube that. That would change which one's biggest potentially, right? We don't want that. So let's keep going. This is really 5 to the half power times 2 to the 1/3 power and to the 1/2 power. Are you guys seeing this? This is to the 1/3, right? That's what this means. But it's also to the half power. This is 5 to the half power, right? This is 2 to the 1/3 power, because we're cube rooting it, right? But it's also 6 to the half power to the 1/3 power. Wouldn't you agree, right? We're square rooting it and cube rooting it, right? Now, check this out. That means I've got 5 to the half power times 2 to the 1/6 power. Over here, I've got 2 to the 1/3 times 6 to the 1/6. Now, what power can I take this to? That's going to get rid of all of those. Taking it to the 6th power is going to get rid of all those, isn't it? Yeah. If we do that, we're going to end up with 5 to the 6 halves, which is just 3. And we're going to end up 2 to the 6 sixths, which is just 1, 2 to the first. Over here, we're going to get 2 to the 6 thirds, which is 2 squared. And we're going to get 6 to the 6 sixths, which is just 6. And none of what we did changed the problem in a meaningful way, right? It didn't change which one was biggest. It definitely made them bigger, but it didn't change which one was bigger and which one was smaller. So now we can easily compare this to compare these. What's 5 cubed?
125.
If we double that, we're going to get 250. What's 2 squared?
4.
So, yeah, it's not even close, right? This is definitely bigger. Note, I am not saying this is equal to 250. We definitely made it bigger, but we didn't change which one was biggest.
They're having a couple off. Or one off. Or something off.
I like that laugh. You ever seen a Goofy movie?
They're having the same thing. No, which one was better?
That was something.
No. Which is bigger, 2 to the 50th or 3 to the 30th? It's hard to tell, but if I rewrite it as 2 to the 5th to the 10th, and I write this as 3 to the 3rd to the 10th, check this out. I didn't change the problem. If I'm taking them both to the 10th, whichever one started bigger will be the biggest, right? So all we got to figure out is 2 to the 5th versus 3 cubed. Which one's bigger? Well, 3 cubed is 27, so 27 to the 10th. 2 to the 5th is what? 2, 4, 8, 16, 32 to the 10th. So which is bigger? 32 to the 10th, right? It's got to be. So that means this was slightly bigger. Not by much, though. Well, when you take some of the 10th, it's going to be a lot bigger, but yeah. Closer than you might think. All right, now we have the problem. to end. Oh, it's so close. Oh, no, it's the next page. All right, this one's not too bad. So, guys, check it out. We have this. You can always split compound inequalities. So I'm going to write this as its own thing. And then I'm going to have 2x plus y less than or equal to 8 as its own thing. Let's go ahead and graph those. We want it where it's equal and where it's less than, right? So let's find where it's equal to first. Can anybody give me two pairs of numbers that are going to make this equal to? Give me two pairs of numbers. 0 and 2. That gets you 0 plus 2 is 2. What's the other one? 1 and 0 is a good one, right? Because you get 2 plus 0 is 2. So that's going to be this guy. That's 1, 0, and 0, 2. So where it's equal to is here. Now I'm going to use a different color for this guy. So a little, oh, they look so similar. They look so similar. Let's use this guy. The Sour Patch, the popcorn chicken, the pizza,
It's not hit well. The chips.
the chips,
Don't worry about the Pepsi.
the Pepsi. It could have been anything.
This is why I only took a singular breadstick, okay?
All right, fam.
I'm gonna struggle with it.
Where is this one going to be equal? 4, 0. And 0, 8 are really easy ones to see. 1, 2, 3, 4. And 0, 8. 2, 4, 6, 8. Okay, now let's do our shading. Pick a point that's not on the blue line. How about 0, 0, right? If I plug in 0, 0, I get 2 less than 0. Is that true? 2 less than 0? 2 is less than 0. No way, no way. So it must be this way. So it's everything over here. That's blue. Everything over here is blue. What?
Last time I tried that, I ended up plotting 4 lines.
This is a different problem. It's on the next page. I made the same mistake just a second ago. All right, this guy. Let's pick a point that's not on this line. How about 0, 0 again? If I plug in 0, 0, I get 0 less than 8. True or false? 0 is less than 8. So this side of the red line must be shaded. But we want where both are true. That's what this means, right? So where are they both shaded?
That little slip.
Here. This is the region that is true for BOFA. We got two more, one of which is not bad at all, and the other is kind of a pain. Okay? Mitch's pool has 10,000 gallons of water in it. At noon, 80% of it is full. How much is 80% of 10,000?
8,000.
We're starting at 8,000, and we're adding on 120 gallons every hour. No, we're losing 120 from the hole, right? And we're adding 225 per hour from the hose. We want to know, when will it overflow? So when will it be greater than, what's the overflow level? 10,000, right? Let's simplify, simplify, simplify. Jason.
What?
Wait, I think I have to picture this like that.
Okay, so we want to know when this will be over 2,000. Guys, let's estimate. If H was 20, wouldn't we get 2,000 and change? Yeah. All right, we get 2,100. So if I do 19, I would remove 105 from that. I get 1995. So yeah, H got to be 20, right? 20 times 105 is going to get you 2,100. So that beats it, right? 19 would get you 105 less than that. What's 105 less than 2,100? Well, it's going to be 1995. That's too small, right? So it's got to be 20. So at H equals 20, the pool will be full. So at 1 p.m., he starts looking. 20 hours later, what's 20 hours after 1 p.m.? Well, it's 3 hours shy of 1 a.m., which is what? 10. At, it's an at symbol. Ah, at.
That's not very good.
At. Yeah, that was good. So it'll be at 10 p.m., 3 hours before 1 a.m. Okay, here's the deal. We want to maximize and minimize this expression, okay? What we're going to do is we're going to find the extreme values of x and y. We're going to plug them in, figure out which ones comes out the biggest, that's your max. Which one comes out the smallest, that's your minimum. To find those values, we need to find numbers that obey all three of these, okay? No, we do not. So we're going to find numbers that obey all three of these. Y got to be between -2 and 2. We got to have y less than or equal to -3x plus 5, and it's also got to be less than or equal to 3x plus 5. So how do we do this? Here's the visual on this, okay? If I were to graph all of these, y has to be between -2 and +2. Here's +2, here's -2, so says me. That means y is between here and here, so this region, right? Cool. We need y less than or equal to -3x plus 5. That's going to be something with a negative slope, so let's just say that's like this underneath here. And we need y less than or equal to 3x plus 5. That's something with a positive slope, so let's say that's right here. What we want to do is we want to look at all the points of intersection. Here, 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 and here. This is just the x-axis, so that's not a point of intersection. X-axis, y-axis. Okay? We want to find the points of intersection. At these points, we're going to get our best numbers and our worst numbers. We don't care about all the other points that we could shade in and everything. We don't care about any of that. All we care about is checking these points, okay? And there will be 5 of them. There will be where the red and the green intersect. That's these guys intersecting. It'll be where the green intersects the black. That's green intersecting this, right? Or where green intersects the black down here. Green intersecting this guy, right? So +2, -2. Where the red intersects this guy. That's this. Or when the red intersects this guy, which is this. So we're going to find all those intersections. How do we find where 2 lines intersect? Chapter 5.
Substitution.
Substitution elimination. So we don't care about the greater than less than stuff because that's where we shade. We just want where the lines intersect. The lines are where it's equal, right? So let's just turn these all into equal signs. So what happens when y is -2? What happens when y is 2? Right? That's what this is. And let's see where y equals -2 intersects this guy. So where does this intersect this green guy, right? Well, if y is -2, we can do a substitution. Y is -2. Let's plug in -2 for y. This one is convoluted. This is the one Landry was like, it's causing a lot of pain. So if y is -2, let's find out where it intersects the green guy, right? If y is -2, what do you add 5 to get to -2?
What? Negative.
-7 plus 5 is -2, right? So what do you times by -3 to get -7? 7/3. So when x is 7/3, this becomes -7 plus 5 equals -2, right? So when y is -2, x will be 7/3. That's where this location is. 7/3, comma, -2. That's a point we're going to plug in here, and we're going to see if it comes out the biggest or smallest compared to all the others, okay? So let's just pause right now. I'm finding out where y equals -2 intersects with the green. I'm going to figure out where this intersects with the red as well. I'm going to figure out where y equals 2 intersects with the green, and it intersects with the red. And I'm going to figure out where these two intersect, right? These red and green. I'm going to check all the points that I get in here. Whichever one comes out the biggest, that's my max. Whichever one comes out the smallest, that's my min. So let's figure out where this intersects with the red. Well, if y is -2, I get this. And again, we're only cared about where it's equal to. What do you add 5 to get to -2? -7. What times 3 is -7? What times 3 is -7? -7/3, -2. So when y is -2, this is -7/3. That is here. Cool, that's where they intersect. Oh no, hold on. Was that red and... Yeah, no, we're good. That's those 2 points. Now let's find out when y equals 2. So let's do it with the green guy. If y equals 2, what do you add to 5 to get 2? How do I make that negative 3? Positive 1. It's already negative. So positive 1, 2 is where this guy intersects with the green guy. So positive 1, comma 2. That's this. Now let's find out where it intersects with the red. So that's when y is 2. But we're using this. 3x plus 5, not negative. All right, so what do you add to 5 to get 2? Negative 3. How do I make that negative 3? Negative 1 when y is 2. So that's this guy right here, negative 1, comma 2. And last but not least, what's the one point we have not figured out? Where these two intersect. Guys, if they're both equal to y, couldn't we just set them equal to each other? You could, or you could do elimination substitution, right? Add them up. It's up to you. I think I'll do a lim substitution. So we got y. I don't care about the less than, so let's just make it an equal, right? All we care about is where the lines intersect. And then y equals 3x plus 5. I think elimination would be perfect here. Let's go ahead and add them. When we do this, we get 2y equals 10. So what does y have to be then? Y got to be 5. So this coordinate is something comma 5. And if y is 5, let's plug in y here. If this is 5, what does x have to be? 0 plus 5 is 5, right? So this coordinate is 0, 5. If you look at my graph, it definitely is, right? It's on the y-axis. Cool. Nice job, Mr. Mack, for drawing an accurate sketch that was completely made up. So now here's what we got to do. We need to check this point, this point, this point, this point, and this point in here to see which one comes out biggest, okay? So, is this going to be a good candidate for coming out biggest? Timesing it by 4 and adding it is definitely going to make a super negative number. It's probably the best minimum, right? But we'll find out later. Let's try all the others, though, okay? If I plug in 1, 2, that's going to get us what? 4 plus 2, right? 6. Congratulations, it is our current winner. It had no competition. What about negative 1, 2? What's that going to come out as? Negative 4 plus 2? Negative 2. Congratulations, it is our current minimum. It has no competition. What about 0, 5? What's that going to get us? It gets us 5. I had high hopes for it. But 0, 5 doesn't beat this, actually. Now let's plug in 7 thirds and negative 2. What is 4 times 7 thirds? 28 thirds, and we're taking away 2. Isn't that minus 6 thirds? So it's 22 thirds. 22 thirds is 7 and change, right? So this is our current maximum right here, actually. It is. This is our current max. In fact, it's going to be our max because this ain't coming out any bigger, right? So this is our max. Our current minimum is this guy, but I bet this beats it, right? Let's find out. If we times this by 4, we get negative 28 thirds. So I'll write that down in pink again. Negative 28 thirds. And then we're minusing 2. Isn't 2 6 thirds? So we're getting negative 34 thirds. That's a little bit more than negative 11-ish, right? So that's definitely going to beat this out, right? So this is our minimum. These problems happen all the time when you're trying to optimize things. Like, how do I rearrange things to make sure things work the best? Turns out this combination and this combination are your best and your worst. This happens in factories, all kinds of stuff. We call this linear optimization. There's like an entire field based on this. Took a really cool class on it in college. All right, that is it. The abomination is dead. 8 is done. Or no, 9 is done. 9 is done. We have done the 8 intermediates. We have done the 7 intermediates. We have done the 9 intermediates. We have done the 10 intermediates. Sorry, Harper, we're doing 8. 8 intermediates. You don't care about the first one, okay.
Bro, why that's the one you use?
On God?
I did that one. I forgot how to do it.
Which one's furthest from the origin? Landry, what is the origin?
0, 0.
So do Pythagorean theorem with these two. How far is 0 going to 10?
100.
Bye. How far is 0 going to 9? Negative 9.
81.
9, so we get 81. So this is going to be 181 rooted. This guy is going to be the exact same thing, isn't it?
Yeah.
Root of 181. This is going to be 121 and 49. So that's going to be 170. so that doesn't win, right? This is 144 plus 25, which is 169. That's exactly 13, but doesn't win. This is 169 and 9, which is 178. Doesn't win. Looks like it's a two-way tie. Yes, no, maybe so? Bye.
So many intermediates.
Okay. Yes, no, maybe?
Yes.
Y equals -5. Chloe, give me a point where y is -5. Give me a coordinate where y is -5. 0, -5 is one of them. Give me another coordinate where y is -5.
Wait.
I didn't hear what you said. What did you say? Well, y has to be -5, so just everybody gets super confused when I ask this question. It's normal. That's why I do this. So you're supposed to be confused, and then you'll figure it out in a second. It's got to be something -5, right? So 1 -5, 2 -5, 3 -5. If I graph those, go ahead. Chloe, here's 0 -5. Here's 1 -5. Here's 2 -5. Here's 3 -5. What is this going to look like?
Straight line.
All lines are straight. All lines are straight. It's horizontal. Now, what is the slope of this line? Check it out. What's the slope? What is delta y? Pick 2 points. How much did I go up between these two?
0.
So it's 0. What's delta x? How much I went to the right? Looks like 4. What's 0 divided by 4? 0. Our slope is 0. And that makes sense because slope is steepness. Is this steep? No. So of course it's 0 slope. Now, this guy right here is x equals -8.1. So that means we need points where x is -8.1. Give me one, Chloe.
Wait, what?
We need points where x is -8.1. We need x to be -8.1. Thank you. So this is true. -8.1 comma 0. 1, 2, 3, 4, 5, 6, 7, 8, and a little bit more. Now, give me another point where we have -8.1 for x. -8.12, -8.13, -8.14. This is going to be a vertical line. Because of course it is. All the x values are the same, but the y values are different. Now, Chloe, let's find the slope. Delta y between these 2 points is like what? 4 or 5, yep, 4. And what's delta x between these 2 points? Delta x is moving right to left. What's delta x? 0. Are we allowed to divide by 0? Undefined slope, which makes sense because this is infinitely steep, and infinity is not a number. Well, we chose 2 random points, and we said delta y is 4, and delta x is 0. 4, 0, 3, 0, 2, 0, 1, 0. Doesn't matter. Yeah, and that'll be true for anything. Like here we chose 4 because we chose these 2. But if I chose these, it'd be 0 over 3. That's still 0, right? Better?
Yes.
Okay.
Yes for the next.
Everybody wants to see this one. All right, it is if you know what you're doing. Chloe, what's the slope here? Thank you. What's the slope here?
Undefined.
Undefined. All right, here's the idea. We're going to estimate. Here's our slope, right? Delta y looks bigger than delta x, doesn't it?
Yeah.
So maybe it's like 4 to 3. We want to know, since it's positive, right, 4 over 3, or actually it's going down 4, right, 3, so it's definitely negative. Since it's negative and we're just estimating, right, we want to know, is it less than or greater than -1? Is -4/3 less than -1, or is it more greater than -1? It's not equal to, bye. So whenever you get a negative slope, which we did, right? See how it's going down and to the right? This right here, we're going to compare it to -1. Is this greater than -1 or less than? You got to be really careful. On a number line, here's 0. Here's -1. Where would -4/3 be? To the left of it, right? -1 and 1/3 is further left. So this is less than -1, wouldn't you say? It's further to the left? Okay, cool. A lot of people goof that up because 4/3 looks bigger than 1, right? Sick. That's very... Do you guys just not like cheese or what? Oh, thanks, Jackson. All right, let's estimate delta y, delta x here. Delta y looks like it's a small positive number because it's going up. Give me a small positive number, Chloe.
Small positive number. 1.
Okay? Give me a large positive number, because this is going to the right. 1 billion. So 1 billion. So this is 1 over 1 billion, right? Delta y is 1. Delta x is 1 billion. 1 over 1 billion. Since it's positive, we're going to compare it to 1. So Chloe, let's compare our slope to 1. Is this bigger or less than 1? 1 over a billion. It's definitely less. It's really close to 0. Let's estimate this slope. Is delta x positive? Oh my god. Delta x is a positive small number, right? Because we're going to the right. Give me a positive small number. 1. Delta y is a large positive number. 1 trillion. That means our slope is 1 trillion over 1 because delta y over delta x, right? Since this is positive, we're going to compare it to 1. Chloe, is our slope bigger or less? It's bigger. Much bigger, right? We did it. So what you do is you estimate the slope, right? And you compare it to positive or negative 1. All right, next page. This one is not on the final. And I don't want to talk about it because it's really complicated. This one right here. Find the slope between the 3 points. Right? Or what is A? It's not on the final. Nope, not on the final. No. It isn't, but what it's going to do is it's going to suck up a lot of time, and you're going to make small mistakes. And so it's basically like, assume everybody does it. If they know what they're doing, they're going to try it, right? And then they're going to make small mistakes, and I'm going to count it for you anyway because it's the final, right? So let's just not and say we did. Save everybody time, right? What's up?
Wait, so, okay, if I try my absolute best, like I know what I'm doing, but I get it wrong, it still counts.
No, it's not if I feel like it. If you have demonstrated, look, I'm an expert, okay? So my opinion does matter. If you have demonstrated you know what you're doing, but then you wrote 3 plus 2 equals 9, you don't know what 3 plus 2 is, but luckily I'm not grading you on that. What I'm grading you on is like, can you find the slope? Can you do this? If you did everything else right, then yeah, you're good, right? Yeah. Yeah, you got to know your crap. That's where you're cooked, right? But you're going to be better after today than you were yesterday, so that's good. All right, check this out. Screenager is pretty funny. That is very funny. I feel like your dad would say something like that. Is this true? No? Okay. Where did you learn this term from? I was expecting you to say TikTok, and I'd be like, ironic. All right. There you go. That is a very good thing to say. All right, here's what we want. I want a point called T that is going to make Q the middle. It's easy if you know what you're doing, right? If Q is the middle, that means we want this number here to make 8 the middle of it and -1. So what number is going to make 8 the middle of it? Here's how we can figure this out. We want to make this the middle. So what number do I need? He's saying 17. He's right. 17 is right in the middle. Is going to make 8 the middle. Now here's why. What's the distance between -1 and 8? So what should the distance here be? Also 9, which is 17. Now, we also want -5 to be the middle. So guess what? It's also 9 away from 4. That's a coincidence. So this distance is 9 as well, which is a coincidence, right? So that means this distance should be 9. So it's going to be -14 because, of course, this is -9 to get there, right? Right, -9 to get there. I am definitely not, but you may have one more slice. Find the equation in standard form. What is standard form? Good, and A and B is sort of our slope. Remember, it's our slope, but one of the signs is changed. A is not allowed to be negative, so which sign should we change? Yep. A is not allowed to be negative, so when we change one of the signs, we should definitely change that one. Now, to figure out what number goes here, what do we need to do? If we do that, we're going to get 9 minus 15, which is -6. Do I see any fractions here? No. Is A negative? No. Then this is standard form. You did it. That's fine. You can totally do that. You're going to have negatives sometimes, because the only way to get rid of them is to times everything by a negative, and that would make this negative, right? And that's not allowed. Turning the page. Prove that the slope is going to be a over b with the sign changed, right? Here's what we're going to do. Take your standard form and rearrange it to look like this, because whatever ends up here is the slope, right? So notice the difference between standard form and this, right? Different letters and stuff. But mostly, it's that y is on its own, right? So I'm going to have to subtract this and divide by b. Let's do that. If I subtract that, I'm going to get this. I'm going to put it before the positive c, just so it looks more like this. And if I divide by b to every term, well, then I get this, right? Notice what appeared next to x. What we always said the slope was, right? Slope is negative a over b. So there you go. You've proven it. It's that simple. It really is if you know what you're doing, right? And that's the key. You have to know how to think. All right. Yikes. Not that there's anything wrong with that.
Yeah, you cannot. At least I think it's 1 to 2 weeks.
Fam, we want to find a line that is perpendicular. What does perpendicular mean?
Reciprocal negative.
Yeah, it means it hits it at 90 degrees, right? So we're not looking for parallel. Perpendicular is going to be the same slope except completely the opposite, right? And we've proven this a couple of times now with some diagrams. Proven, right? It's a visual proof. We know this is kind of our slope, right? What we want is the same slope but the exact opposite. We want 4x and 3y. See how it's the same slope but the exact opposite? Now, we also want to negate one of the numbers, right? If I just flip these, this would be 4x minus 3y. I have to negate one of them. Am I going to negate this? No, because then it wouldn't be standard form, right? So I'll negate this and make it positive. Cool? So it's the same thing here, just flipped, and one of the signs changed. Now, it's not going to equal negative 8. Instead, they want it to have the same x-intercept as this guy. So what do all x-intercepts have in common? 0y. So if we plug in 0y, what times negative 3 gets you negative 8? 8 over 3. We already have the negative, so it's just 8 over 3. 3's divide out, you get negative 8, right? So it's 8 over 3. So we want this to go through this point, right? So how do we figure out what number goes there? Plug that in. If you plug in 0, that's gone. If you plug in 8/3, what's 4 times 8/3? So 32 over 3 plus 0 is this. What's the problem?
Fraction.
Says we got to write it in standard form. This is not standard form because we have a fraction. How can we get rid of it? You times everything by 3, you'll end up with the actual standard form of that line. This line will hit it at 90 degrees, and it'll also go through that point. All right, now it's saying we want a line that is parallel to this. Parallel means same slope, right? So if I rearrange this to standard form by doing this, if they have the same slope, then the line we're looking for is going to look exactly the same. It's just going to equal something else, right? Same slope, right? Now, Chloe, it's not going to equal negative 3 because we want it to go through negative 1, negative 7. It's going to have the same slope, but it's got to go through here. So let's go ahead and plug that in. We get negative 2 plus 42. Well, that's 40. This line goes through negative 1, negative 7, and has the same slope as that one, so it's parallel. We are done with chapter 8.
Oh yeah.
The only one we have not done for the intermediates is 6. So shout out to Harper. Apologies to Harper. I will do all of 6 whether you like it or not, unless you guys, for the time we have left, would rather do some spicy problems for anything else. Okay, normal 6. All right, go ahead and get yourself situated. Abigail asked an hour ago if I have kids and think I will be late here. So you have your answer. Answer is yes, clearly. Alice changes size several times. So this is Alice in Wonderland. Her original height to her second height is a ratio of 8 to 3. So let's write that down. That's 8 to 3. For every 8 inches or 8 feet, she's now 3 inches or 3 feet or something like that, right? We know her second height to her third height is going to be 6 to 1. Okay. Now, let's pause for a second. These are not apples to oranges, right? See how H2 is represented by 3 and by 6? These aren't really comparable. So what can we do so that it's easier to compare these? Hello. Yeah. If we double everything over here, it keeps the relationship, right? For every 8, there should be 3. So for every 16, there's 6. And we can clearly see that H1 is the biggest now, right? Now, we're not done, because H1 to H4, they said, was 7 to 2. Does this change which one was biggest? We said H1 was biggest, right? Does this change that? No, it's still bigger than H4. We know the biggest is 4 feet, right? So we should really represent this with a 4. So that means we should really represent this how? If this should really be a 4, exactly, so 6 quarters, right? 6 quarters of a foot, 1.5 feet. That means this should be 6 quarters, and this should be 1 quarter. Now, we could get these to match and everything. That would be totally fine, but we already know that this is going to be the smallest, right? It's got to be. So this is what we want. 1/4 of a foot is her smallest height. Yeah, if we make this last one 4, we definitely times by 4/7 to get there. So if we do that to both of them, what we're going to get is that this is 8/7, which is clearly more than 1/4, right? So this is our smallest. That one's one of the worst ones. This one's kind of tough too, okay? All of these are kind of tough, I'm going to be real with you. My piggy bank has only pennies and nickels in it, so here's the deal. N is the number of nickels initially in the bank, and P is the number of pennies we're starting with. So how do I represent the total amount of coins? Here's how many nickels I have, here's how many pennies I have. What's the total amount? How can I represent that? Yeah, N plus P represents the total amount of coins. It says 2/5 of my coins. 2/5 of means multiply, right? Thank you again. 2/5 of my coins are nickels. Cool, all right. Then it says if I remove 300 pennies. Well, now I don't have N plus P anymore. I have N plus P minus 300, right? That's our total amount of coins. 3/7 of that will equal our pennies. Now, here's the mistake I always make, especially when I'm tired. If I've removed 300 pennies, is this how many pennies I still have? No, that was the original amount, right? Now I have whatever P minus 300 is, right? If P was 1,000 pennies originally, if I moved 300, well, I don't have 1,000 still, right? I've got 700. So remember to put that minus 300 there too. What we're going to do is we're going to clean this up and do elimination substitution. In the top equation, I'm going to times everything by 5 and distribute by 2. So if I distribute the 2, because it says times, right? I'm going to get 2n plus 2p. And if I times by 5, that's gone, and I'll get 5n over here. If I simplify further, I'm going to get 2p equals 3n. In the green equation, I'm going to distribute the 3 and times everything by 7. So if I distribute the 3, I'm going to get 3n plus 3p minus 900. And if I times by 7, that's gone, and I got to times all these by 7. 7p minus 2100. If I clean this up some more, getting p's and stuff together, what I'm going to do is I'm going to add 2100 to this minus 900. So if you do that, 2100 minus 900, that's going to be 1200. If I leave the 3n, that means I've got this. And if I subtract the p's over, I get 4 p's. So now I've got these two. Now the problem is that I've got two variables in both, right? Two variables in both. Now I've got an option. I know 3n equals 2p, right? So can I replace 3n with 2p? Then I'd move that over and I'd find the pennies. Once I have the pennies, I could plug it back in, find n. But what we really want to know is the nickels, right? So check this out, check this out. If 2p equals 3n, doesn't that mean 4p equals 6n? This is a better move, although both were okay, because now I can replace 4p with 6n, and now I'm talking about just the nickels, aren't I? And now I can just find the nickels. Subtract 3n. What times 3 gets you 1200? 400, very good. 400 nickels. Turning the page. My baseball team lost 9 out of 13 of its games this season. If we lost 15 more games than we won, how many games do we play? So we want to know how many games we played. That's W's plus L's, right? That's total number of games, W plus L. So first off, is this true? W equals L. No, that means you got a 500 record. Did we win more or lose more? We lost more. So if I add 15 to the wins, it'll be equal to the number of losses, right? So that's what this is. The other thing we know is we lost 9/13 of, that means times, right? Of our total games. How do I represent the total amount of games? W plus L. Yeah, you could. There's a thing, and that might even be better. I don't know where. I think I know where you're going. There's a better way to do this, but this is guaranteed. So 9/13 of the total games are what? Are they wins or losses? 9/13 are what? They're losses, loses. So we have this. That's okay. Elimination substitution. We know L equals W plus 15, so replace all the L's with W plus 15. You could do that, yeah. Let's do that. So I'm going to plug W plus 15 into the other equation. So let's do that. We have 9/13 times whatever W is plus whatever L is. Remember, L is equal to W plus 15. And that'll equal L, which is W plus 15. Let's combine stuff. Looks like I've got 2 W's plus 15 in here. Equals W plus 15. And now distribute the 9 times everything by 13, kind of like we did in the other problem. I'm going to do that up here. So if I distribute the 9, we're going to get 18W plus 9 times 10 is what? And 9 times 5 is 45. So if we add those up, 135. If I times by 13, that's gone. So I distributed the 9. I'm going to times by 13 to everything. I get 13 W's plus, oh look, 90 and 45 again, so 135. Did I goof somewhere? I feel like I goofed somewhere. 18W, 135 times by 13. Oh, 13 times 15 is not 9 times 15. My bad. So we times by 13, that's 13W. 13 times 15, what's 13 times 10? Very good. And what is 13 times 5? 50 and 15, that's 65, right? So we have 130 plus 65, 195. Nice job, Chloe. 6 dub equals, subtracting that over 60. So we got 10 dubs. Well, we got to figure out what the L's are so we can figure out the total number of games. Well, apparently if you add 15 to the W's, you get the L's, right? So how many L's we got? Well, if W is 10, how many L's will we get? 25, yeah, 25, yeah. So L's is 25. How many total games is that? Don't tell her, she was on a roll. Oh no, that's not good. All right, in a far off land, 8 fish can be traded for 5 loaves of bread. So 5 bread. We know that's the relationship. For every 8 fish, you can get 5 bread. A loaf of bread, so 1, can be traded for 3 bags of rice. So 3 bags of rice. We want to know how many bags of rice is 1 fish. So we want to know this. These are hard to compare because they're not apples to apples. What can I do to make these more comparable? Yeah, if I make this a 5, I times by 5, so this should be 15, right? So now we can easily say that 8 fish is worth 5 bags, which is worth 15 rice. So we know 8 fish is worth 15 rice. So now the question is, what's 1 fish worth? I turn this into 1 by dividing by 8, right? 15 eighths. That's probably why they don't allow you to trade 1 fish for rice. Instead, you have to trade. Yeah, it's almost. It's really, really close, but not quite. While eating out, Mike and Joe each tipped their server $8. Mike tipped 20% of his bill. So $8 is 20% of his bill. hold on. M is Mike's bill. If $8 is 20%, what's his whole bill? How do you get 100%? Times by 5, right? So it's got to be $40. That was his original bill. Joe's bill, apparently 25% is 8, right? So what was his entire bill? 25% of his bill was 8, so if we times it by 5, we get 100% of his bill, 32. They want to know what the difference was in dollars between their bills. So what's the difference between their bills? $8. $8. Every day, 40% of the fish are sold. There are 7,200 fish left at the end of the day on Tuesday. How many were there when the store opened on Monday? So 2 days pass, and this is how much is left. So check it out. F is the total amount of fish we had originally, right? If 40% are sold, how much are left? 60% of the original amount is left after day 1, right? So 60% of F. After day 2, we sell another 40%. Isn't that another 60% left? 60% of day 1's fish. And at the end, we're getting 7,200. So let's find F, which is the original amount. Let's simplify, simplify, simplify. This is going to be 6 over 10. This is going to be 6 over 10. And if you notice, this is going to be 36 over 100, right? 36 over 100F equals 7,200. 6 times 6, 10 times 10, right? We're dividing by 10 twice, which is 100, and we're timesing by 6. So now we can either divide by 36 or times by 100 to get F on its own. I'm going to divide by 36, actually. What is 36 over 100 divided by 36? 30, don't simplify. I'm dividing by 36. What is 36 hundredths divided by 36? It's 1 over 100, yeah. And the reason I divided by 36 is because 7,200 is divisible by 36. It is. 200, or hold on, is it 20? We're going to get 600. Yeah, it's 20 times 36 is 7,200, right? Because 2 times 36 is going to get you 72. Times by 10, you get 7,200. Hold on. 72. 720. I knew I was wrong. There we go. 2 times 36 is 72. We need 2 more zeros, right? If we times by 100, F is going to be 2,0,0,0,0. 20,000 fish initially in the store. That's a lot of fish. We got one more. Just one more. This one is really difficult looking, but it's actually really easy. Do not write anything down until I say, okay? We want to know, what is the ratio of acid to water? So what we're going to do is we're going to put total acid over total water, okay? Do not write anything down. Total acid over total water. All right. 25% acid and 70% water, 75% water is mixed with 15% acid and 85% water. Notice we're using twice as much of this. That's what this says, right? Okay? So initially, how much acid did we add? Well, we added 25%, right? 25% of however much we added. So I don't know. Let's use S for the amount of solution. Maybe it was a gallon. Maybe it was 10 liters. Maybe it was 34, whatever. I don't know. But it was 25% of however much we added, okay? That's acid. Then we did 15%, but we did twice as much, right? So 2S. You with me on that? If this was a gallon, this will be 2 gallons of this. If this was 10 liters, this will be 20 liters of this, okay? They do, and I'm sorry. Now, that's a good point. I should probably try that. 75% water was added, right? So that's 75% of the solution was water. And here, 85% of twice the solution, because again, we're doing double. Now check this out. What common factor does the top share? They both share an S, right? We can take that out. We can also take out divides by 100 from both, can't we? So what we're left with is S over 100. We just took that out. And we're left with 25, right? And we're left with 15 times 2. Are you guys seeing that? Took out the 100, took out the s, or 15 times 2. Took out the 100, took out the s, we get this. What's even cooler is the bottom also has factors of s's and hundreds, right? So we can take out 100s there, and we're left with 75 plus 85 times 2. Notice that this is something times something divided by something times something. We can divide these out. They're useless. You don't even need this to start your problem. You do 25 plus 15 times 2, and 75 plus 85 times 2, because we're doing twice as much. Sometimes I change it to triple or something, right? And that is going to be your total acid over your total liquid. So 25 plus 30, that's 55. And this is going to be 75 plus 160 plus 10, which is 170. So 170 plus 75 is 245. Do I agree with that? This is the relationship, yes. So don't write any of this down. Just make note, 25 and 15, but we're using twice as much of 15. 75 and 85, but we're using twice as much of the 85, right? Total acid over total water. Really, really easy if you see that these things go away and you can just ignore them. That is all. That's it. That's it, Harper. We did them all. Sorry it was so late. Well, I think that's it. Go away. Go home, relax, 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 and then study. But try to get some sleep. That's super important. You can't be exhausted when you show up here. I'm sorry. Your family won't turn on the AC? Yeah, same at our house. I've gone dad mode. I try to keep the AC off as long as possible. It is, I'm going to be real. Oh, hold on. That's the end of the show, everybody. Bye.